Hello everyone. In this video, I want to show you how to use the optimization feature of QAquifolium. So for this purpose, actually, I'm not gonna build a model from the scratch because it's gonna take some time. The model is, it takes some time to put all these components together and create the model. I'm gonna use a model that I've already built. Now you can use the same instructions and same steps that I'm gonna go through to optimize, any problem that you have, any model that you have created. But I'm gonna also post the script of this model on the website and also on the YouTube video, and you can actually try it. Try this one in case you want to do it. So let me just briefly explain what this model is. So this is supposed to represent a very simple model of a stormwater pond. So what we have is that we have a catchment right here that receives precipitation. I have a 1-year record of precipitation that I've already applied to this catchment. So it rains on this one. The water goes to a stormwater pond. The stormwater pond has basically 2 outlets. One of them is an under drain, okay, which I represent as a weir. Because it's easier to parameterize. Now you can use a pipe instead of a weir or any other outlet type, any other governing equation that controls the outflow. And then it has an overflow. Right now, because of the fact that in Aquifolium I can't have 2 connectors connecting essentially 2 unique blocks, I need to add this additional junction. So what happens is the under drain goes to this junction, and then it flows into the second junction, which is called junction 2, and then the overflow directly goes to junction 2. And these junctions are rigid junction type, so essentially whatever flow goes into them goes out. And then so the water, essentially the flows, the overflow and the under drain flow are added to each other, and then are basically they flow out into a fixed head boundary condition. And what I'm going to do is that basically I wanna essentially define my objective function on the total flow. What I'm going to do in this example is that I will try to make basically minimize the variance of flow over the period of simulation here by adjusting the coefficient, the discharge coefficient of this weir, right? So the coefficient alpha right here, I'm going to basically treat that as a parameter, and then I want to find what coefficient will result in the minimum variance of flow. And now that may not be very realistic. I mean, you may want to do it differently. Someone may, in other problems, you may want to minimize the volume, or you may want to minimize the maximum, the peak flow, or so on, and that can be easily done. Now, so let's get started. So let me move this window out of the way. So basically what I do is that the first thing I'm going to do is that I will define this parameter. So I have to define a parameter. So in order to define a parameter, I'm going to click on this, the parameter tool button right here. So if I click on that, it's going to add a parameter right here for me. I can change the name of the parameter. So since this parameter is supposed to represent the drainage coefficient, I'm just going to call it drainage. Drainage coefficient. And then I'm going to define some. I can define a value. So the value that I've assigned is 10. So I'm going to leave this at 10. And this value is only used if you want to run the modeling forward when we assign the parameter. So this is the value that is going to be used. And then we have it. So since the value is 10, I'm going to pick a lower limit of, let's say, 2, and then I'm going to pick an upper limit of, let's say, 70, or I don't know, let's say 100, right? So basically I don't know what the optimal value is. I know it's something between 2 and 100. Now there's a chance that the optimal value may be outside of this range, in which case when I run the optimization, the solution will be will either stick to the ceiling or the floor of the limit, and from that I will understand that, okay, so I need to probably expand the limit in order to find the actual optimal value. So okay, with that, so the next step is I want to assign this parameter now to what I want to assign it to, which is basically this alpha coefficient right here for this where. So in order to do that, what I'm going to do is that I will right click on the name of the property, and then this pop-up menu shows up that shows parameters, and then the only parameter that I have is drainage coefficient. So I'm going to pick that parameter, and that's pretty much it. So I assign this the parameter that I defined to the coefficient alpha of the where. Now you can do it for any other parameter. You may want to optimize different things. You can do it, and of course we can have multiple parameters as well. Now this is going to be a very simple problem because we only have one parameter. So this is a very simple optimization parameter, but in real cases the problems can be more complex. And now the next step is that I want to define my objective function. So this is the objective function. So essentially what I'm going to do is that I first add an objective function. So I go here and I click on this this bottom that represent objective function. So I click, I'm going to get an objective function right there. Again, we can change the name. Let's say I'm going to change it to flow. And the next thing is I want to say where I define this objective function. So under object, there's a drop down menu. I'm going to go and pick essentially what the object that I'm going to basically define the objective function based on is this junction 2 to fixed head 1 right here. So it's basically junction 2 to fixed head 1. That's the one that I'm going to define. No, I'm sorry. Click on the objective function, flow, and then the object that I'm going to pick is going to be junction 2 to fixed head 1. The expression is going to be flow. So I'm going to basically use the flow as something that I'm going to calculate the objective function based on. So I'm going to type flow. There's actually a drop down menu that gives us the variables that are the variables of this object. You can also have expressions. We can actually, let's say you want to minimize the log of flow. You can just simply type log of flow. Then the calculation method, there are several options. So there's an integrate. So what the integrate does is that it basically calculates the integral of flow over the simulation period, which in this case is going to be constant no matter what, because ultimately there's no infiltration and evapotranspiration in our model. So ultimately all the rain will become flow in that link. So basically we can't really optimize volume, but there may be other cases where you can do that. The value looks at the value at the end of the simulation period, and then we have maximum. But what I'm going to do is that I'm going to use the variance. So I'm going to pick variance. And that's pretty much it. Our system is set to perform optimization. Oh yeah, one more thing. We can change some of the tweaking parameters of the optimization. So if I go to settings and then I click on optimize, you'll see some basically parameters that are used for the genetic algorithm to conduct the optimization. So the first one is the population in the genetic algorithm. The second one is the number of generations. And then there are some other parameters that I'm not going to go through. There's a crossover probability and mutation probability. You can leave them all. Now the only thing that I'm going to do here is, because it's a very simple optimization problem, I expect to be able to get pretty close to the optimal value with maybe a few generations. So I don't really need to have 40 generations. In a real complex optimization problem, you probably need more than this. So you can always play with the population and number of generations to get the results that we want. But so what I'm going to do here, since this is a kind of a tutorial and I don't want to wait too much, is I'm going to change this number of generations to 5. Okay, so now with this I think we're ready to go. Everything is defined. So the first thing, I can of course run the modeling forward. So if I run the modeling forward, I can see some of the results. For example, I don't know, I can see this is my precipitation. So this is the precipitation that occurred on my catchment. Then I can look at the under drain flow. So if I look at the under drain flow, this is what we see. So we see that the peak of under drain flow is around, I don't know, maybe 8.5. We can look at our overflow. So basically this is our overflow. We had some big events later in the year which caused some overflow. Other than that, we had a little bit of overflow before that, and then the total flow going out, which is a sum of the two, the underflow, under drain and overflow, is going to be here. So okay, this is what we have using the parameter 10. So this is based on the parameter value 10 that we assigned its value right here. So now what I'm going to do is that I will do the optimization. So in order to do the optimization, I'm going to click on this optimize button right there, and it'll start doing the optimization. There are two progress bars here. The bottom one shows, the simulations during each generation. So when it gets to 100%, that means we're going to proceed by one generation. And then the top one is, of course, the generation percentage. So when we get to 100% in the top progress bar, that means the work is done. So what I'm going to do is that I'll stop recording right now, because I don't want this video to become too long and boring. And then when we get to a certain stage, I'll just continue. Okay, now the optimization is finished. It took a few minutes. It didn't take that long, but I mean, in a real complex problem, it may take much longer, depending on how long each simulation is and how many generations and population we want to simulate. So let's look at the results. Okay, so basically the first thing we want to see what the value of the parameter is, what value was determined. So if I go to parameter, click on the parameter, you'll see that the value that is found is 95.96. Which is, this is our optimal value that will minimize the flow. Now we can actually run the model with this, but it's already the result that is already stored in the system is based on this value. So I don't have to run it using this parameter, run it in forward again. All I have to do is I can look at the results. So for example, I can look at the flow here, and this is the flow that we see in the total flow. I can look at the under drain, which now should be a much higher value compared to what I had before. And as you can see, we get around 50 or 60. Okay, so the maximum flow actually is going to be 60, and then I can look at the overflow. So this is the overflow that we're now going to get. And that's pretty much it. Thank you for watching. Look for my future videos.